example 3 on section 5.4. I'm actually going to do this problem in two parts because it's going to take too much room to figure out what these derivatives are and then also do all the rest of the stuff that we have to do. So let's just go ahead and we'll call this part 1 of example 3, where we actually have to find these derivatives. So the first thing we'll want to do is, well, take the derivative using the quotient rule here. And I'll refer back to this in the next video. I'll just write down what we got for the derivatives, and we'll do all the rest of the problem on the next part. Okay, so the first derivative, we need to use the quotient rule. Remember what that says, low d high, right? So low, the bottom function, times the derivative of the top function, which is 8x, minus high d low, so 4x squared. The derivative of the bottom function is 2x. And we divide all this by the bottom function squared. X squared plus 4 squared. I'm hoping that all of this is showing up. Just lower that a little bit, make sure that you're seeing it. Okay, so let's simplify that derivative. We're also going to have to find the second derivative. So we're going to get, we'll distribute that 8x to there. We're going to get 8x to the third plus 32x. And then for the second part, we'll have minus 8x to the third. And it's still dividing this by x squared plus 4 squared. Okay, notice that nice and handy, these 8x to the third power terms cancel, so we're going to have 32x over x squared plus 4 squared. Okay, so there's our first derivative. Again, all we're doing on this part is just simply showing what these derivatives are, and then we'll use them in the next part. Okay, so now we need to find the second derivative, f double prime. Again, we'll have to use the quotient rule. So this time, again, it's low d high minus high d low. So low, x squared plus 4 squared, d high, the derivative of the top function is 32, minus high 32x. The derivative of the bottom function is going to require the chain rule. It's going to give us 2 times x squared plus 4. Lower that power by 1, multiply by the derivative of the inner function, 2x. So we get that. Divide all this by x squared plus 4 squared, and then squared again gives us a fourth power. Okay, so what we can notice to make this a little bit easier to simplify is that I've got a common term here. X squared plus 4 appears both here and here. There's only one of them here, there's two of them there. What I can do is factor out, in fact, let's go ahead and factor out the 32 as well, since that's common to both. So we'll factor out a 32, and we'll also factor out an x squared plus 4. Okay, now what is that going to leave us with? So what I did is I factored out a 32, so it's going to be gone from here, and I factored out one of the x squared plus 4s there, so I'm going to have only that left, x squared plus 4. Now minus, I factored a 32 out of this, I factored out of both of them, so that's going to leave me with minus. And then I also factored out that x squared plus 4. Well, what does that leave me with then? 32 is gone, the x squared plus 4 is gone. I'm left with 2 and a 2 and an x and an x. That's 2 times 2 is 4, and then 2x is 4x squared. Okay? And then this is divided by our x squared plus 4 to the fourth power. Now notice why it was beneficial to do this, to factor that term out, because now I've got 4 of them in the denominator and 1 of them in the top. So I can cancel, leaving me with a third power in the denominator. And then we can simplify what we have left. I've got a x squared minus 4x squared, that's minus 3x squared. And then if I multiply that by 32, that's 96, right? So I'm going to get 96x squared, negative 96x squared. And then if I distribute that 32 into the 4, I'm going to get 128. So 128. And then this is divided by our x squared plus 4 to the third power. I just want to make sure I did that exactly right because I don't want to mess this up for next time. So let's see. That looks right. Yep, I think we've got that correct. Yep, so there we go. So there's our second derivative. Okay, now, in fact, actually, I think it might just be better to go ahead and leave that 32 out of there. Let's just write it like this, 32, and then we'll have a 4 minus 3x squared. Okay, so just keep that in mind for what we're going to do on the next part of this problem. We actually have to use these derivatives to figure out concavity, increase, decrease, all that kind of thing. Okay, so have those written down for the next video. We'll continue.